Join with computer audio.
Lecture. So as I mentioned in our previous classes, I'm very happy to introduce today's speaker, Yangqing Jia. So I think you should know him. So read his bio. Yangqing is the co-founder and CEO of Latin AI, with a startup helping enterprise to run AI application efficiently at scale and in minutes. Before this, Yangqing served as VP of Alibaba on big data and AI, and he led AI infra at Facebook. And before that, he did research with Google and Bring, and he created contributed to open source libraries such as Athena, ONNX, and PyTorch. I believe everybody knew those things. Yangqing graduated from UC Berkeley with a PhD in ECL. I think very humble, very short one. So, but anyway, let's give our applause.
Thanks so much. And I'll just turn this on so that it's a bit louder. Yeah, it's a great honor to be here. And actually, I visited Duke a few years ago, and also thanks the Professor. Yeah, was a PhD community. Although I was honored to be in the community and wasn't really kind of too qualified as a professor. My background is basically I graduated from Berkeley, and then towards the end of my PhD life, I started basically getting really interested in AI software and infrastructure and things like that. My PhD topic was actually computer vision. Before computer vision was cool, and my fear was that I'm going to be like losing my job after all, losing like my opportunity to get a job or things like that after graduation. So towards the end, it was like that was 2012, 2013, and there was AlexNet, and that was the beginning of all those deep learning stuff and all kind of frenzy things followed after these years. And I found myself going from research, doing algorithms and papers and things like that, upstream to systems, to a little bit of hardware and things like that. And so my experience became a mishmash of all kinds of crazy little things. And when Professor Chen was basically asking me to give a talk, I was like, well, what do I talk about? I don't really have papers, and there's not really like charts and things like that to talk about. So it's like, why don't I just like share a little bit of kind of like the things I kind of learned over the years and my little opinion about what the fundamental infrastructure cloud has been going, given all those AI and impacts and things like that, right? So first of all, let's basically talk a little bit about like how hard it is today to build something like that's AI related and things like that. Back then in 2012 or even earlier, then there's quite a lot of difficult algorithms to implement and things like that. So it's kind of relatively hard to make something that has AI, quote unquote, in it. So let me show you one example, which is like something that we released a few years ago. A few weeks ago, not years ago. Sorry. And it's called Search, or Lepton Search. And the code is open source, 500 lines of code, so you can actually look at it. The idea is, kind of similar to all those conversation engines out there. There is Google's Gemini. There's Bing Chat. There's also really awesome startups like Perplexity that does it. And we're like, how do we do it? So we basically build a search which can answer questions in a conversational way. So let me see. Let's basically say, who is Professor Yiran Chen, right? Just to do that. I haven't tried it, so it might hallucinate, but let's see. Professor Yiran Chen is John Koch Distinguished Professor of ECE at Duke University and things like that. I think that looks pretty correct. Under the hood, what it does is basically it rewrites that query. It takes that query to bin, basically say, hey, give me a conventional search, 10 results, which is actually listed down there. And then each search result comes with what we call a snippet or SERP, search page summarizations. I basically take all those summarizations, I combine them, I attach the citation numbers, and then I ask a large language model, hey, give me a natural language answer summarizing the search results. And by the way, give me the citation numbers. I didn't do anything other than basically telling the conversation engine, telling the LM, give me the citation number after each sentence. And that's basically the result they gave me. really pretty cool and things like that. Now, of course, if you want to really put it into real products and things like that, there's quite a lot of, like more difficult things to do, right? But that's good, like basically like we did it in a weekend. One of the biggest challenge for me to do that was actually the front end. I started using Flask, which is a terrible Python web server. My colleague back in Lebanon AI, he's doing front end. He was like, dude, that's way too stupid. I was like, just throw out that code. I'll take your Python code. I'll write a really nice front end, which is the one that you see right now. And that's how it was done. It was like basically 2 weekends, one me tinkering around with things, and one weekend he does that thing. So we kind of started basically extending from there and basically say, how do we actually make this more local and more personalized and more helpful, right? So what I'm going to be showing you next is probably the first time any external person has ever seen this, because we're planning to release it, but not yet. So the idea is it can basically just be plugged into your Chrome browser. So say we have a Wikipedia page, it's way too long, as all Wikipedia pages are. And we can basically have a Chrome plugin that naturally reads it for us and starts answering questions, okay? So that's the Chrome plugin. Just click it, starts the side panel. It basically parses all those content of the page, which runs locally. It doesn't have anything to do with the remote service yet. And it can basically start asking questions. When is Duke founded, for example? Is Duke founded? The font is a bit small, so I just like read it for you. It's basically founded in 1838, which I believe is right. And we can basically say, who are some of the famous alumni of Duke, right? And it basically says, well, Richard Nixon. Oh, wow. Sorry, let's wait for it to finish. That's too long a list. It's great. That's a lot. Oh yeah, great achievements. So yeah, basically, like I'm not sure if it starts hallucinating, but probably yeah, stop generating. And let's look at the very first ones, right? So I think probably at some point it starts hallucinating, but Richard Nixon, Melinda Gates, Elizabeth, Tim Cook. Oh, Tim Cook. Whoa, yeah. Also, I didn't know about that, but this is great, right? So basically, imagine like for all kinds of today, web browsers are becoming one portal of us getting information. And imagine if there is, like an assistant that helps you to go through all those kind of interesting pages and things like that, and starts answering things as a constantly on assistant. In enterprise environments, as long as you have a dedicated web server, this whole thing is completely low. You using Silicon Valley kind of like jargon, it is basically solo mo. It's very local. It's very like mobile, and well, there's no social components, but yeah, it's very convenient. Today, it's really easy for us to basically write, like examples using applications and things like with AI, and that's like one of the great things that we have seen over the years. So I've been basically started in Berkeley. I went through all those big companies, Google, Facebook, Alibaba, and then a bunch of us were basically a bit tired of the big corporation stability and things like that. We're like, well, we wrote quite a bunch of open source software. Why don't we start doing a small company? So it's kind of small. Interesting trivia is that we rented an office, mainly because it was cheap. And then we found that it was the very first Apple office after they moved out of the garage. So hopefully we get some good luck, but still we might die anyway, any day, right? But it's so far a fun experience. All right, so I'm basically going to be trying to basically answer or basically like introduce some of the topics I've been thinking about for a while. What are some of the common characteristics of AI compute? Does the model size, the compute size, all those things matter? Should I have my own models and things like that? And with all those kind of AI crazy frenziness, what does it mean for infrastructure? Right? And there are quite a bunch of interesting questions that I'll basically put inside the talks. There's the very famous car salesman dilemma. There's good, fast, and cheap. The properties that people want to achieve, but usually there's only two options. This kind of applies for applications, for modules, for infrastructure, and we'll see a few examples, especially on hardware side. So first of all, one thing that we've been repeatedly seeing is that, I'd love to basically summarize it as AI has becoming the third pillar in IT infrastructure. Now, what it means is conventionally, well, I'll show this later, but like let's basically talk about what kind of pillars there are, right? So starting from 2008 or even earlier than that, there's the emergence of cloud. And that's mainly because, like people find that the internet has been a pretty awesome thing for delivering information. So there's all kinds of websites and things like that. And that creates the very first pillar, which is web services. Right now, before that, there's all kinds of HPCs and physical simulations and things like that. But let's pretend that we forget that for a while and start from web services. The idea of web services is that there's quite a lot of I/O. You basically move data around from the servers to the users' browsers to mobile and things like that. People run arbitrary Python code or like JavaScript code and things like that. But it's an embarrassingly parallel system. There's a lot of people visiting a website. You have quite a bunch of web servers pulling up if there's more traffic and scaling down if there's less traffic. And the major part is basically to move data around. And that basically created, one of the biggest cloud providers, AWS. And if you think about it, the name is actually not Amazon Cloud, it's Amazon Web Service, AWS. And then basically, with all those web things and things like that, and also with all like online transactions and things, there's quite a lot of data. And data actually predates internet, but it has always been, and in the internet era, it has been ever more important. There's quite a huge amount of data that we need to do summarizations, we need to do business insight, BI, and all those kind of things. And so database has become more and more important and has become arguably the second pillar in IT infrastructure. Right? It's rather different from web in the sense that, like I/O is still quite important, but there's very simple abstractions like SQL and things like that, and it involves very distributed systems. Imagine if, when we are learning those things from DBMS classes, you basically learn all those things about how to actually convert one SQL line into the query plan, how to actually go from the logical plan to physical plans. You do, like a sorted merge join or hash join, things like that. And all those kind of things actually run in a big distributed system. Right? If you run Hadoop, for example, some of the largest Hadoop clusters involves tens of thousands of nodes and stuff like that. And out of that emerges very important companies such as Databricks and Snowflake, and also like the cloud providers, AWS and Aurora and things like that. So people have successfully convinced the companies, corporations, that data and web services are actually two very important parts when they think about IT. Now, the third one is AI, in the sense that AI is very much different from the former two because compute outranks I/O in that case. If you think about GPUs and things like that, we deal with a couple of gigabytes, a couple of terabytes of data, but you train that model for a couple of days, if not weeks or months, right? We still run arbitrary Python code, and also it's still very distributed systems, but it's pretty complex in the sense that you no longer have the luxury of writing the SQL and be done with it. You usually write things in like, say, in like DeepSpeed or raw PyTorch and things like that, right? So, and then the spending has been so big that people started feeling, at least today, and I love to think it that way, that AI has becoming more and more important and becoming equally important compared to data and web. Now, this can be actually verified by the number of growth, the star growth in GitHub. So basically, like when we basically started writing Caffe, which is a fond memory of me, of course, the stars we thought was growing really great. It was like growing to something like 20,000 stars, that one of the biggest in my career, right? And then basically PyTorch came out with a much higher speed. And then Hugging Face Transformer came out, which is hugely popular today. And if you're doing AI, you definitely want to use Hugging Face to find models and things like that. And last year, there was this interesting project called AutoGPT. And within, like a month or so, it reached something like 140,000 stars. Now, there's definitely quite a bit of, frenziness and FOMO mindset over there, but nonetheless, it tells us the importance and the interest that people have about AI, right? And actually, like as early as 2019, Professor Richard Sutton, who was the pioneer in reinforcement learning and robotics and things like that, he basically said, like the biggest lesson that can be read from 70 years of AI research is that general methods, neural nets and things like that are extremely flexible and extremely scalable is actually pretty good. General methods that leverage computation are ultimately the most effective and by a large margin, one of the most effective approaches, right? In the past, as a computer vision student, for example, we designed handcrafted features such as SIP and HOG. And if you're actually doing speech, you might remember the old features like MFCC and things like that, right? And then if you're doing NLP, then you probably remember things like PCFG and all those, like, I'm not sure if I actually remember the term right, but basically like parse trees and things like that. Today, a lot of things are basically just done by neural nets. It's arguable which one is better or worse, because we still have, people arguing that neural nets being such a big black box is not that great in understanding the details and the logic and things like that, but nonetheless, it works pretty well. That's the kind of idea that we're having. And then basically, like, we started thinking about, like, do computation size matter, do model size matter, and things like that. And one thing that we found is that sometimes we've actually gone through the very first stage, which is getting things larger, getting models larger, things like that, and starts finding that some of the models, if we're actually able to do more vertical area or fine-tuned kind of models, it actually performs pretty well. Now, let me basically recite the history of model sizes a little bit. In computer vision, we started with AlexNet, which is something around 6 million parameters, if I recall correctly, 60 million parameters, if I recall correctly, which amounts to something like 240 megabytes. Now, that was 2012. And then very quickly, over the next few years, the model size grew enormous. And then VGGNet, which was, I think, if I recall correctly, 2014, I think, that was 1 gigabyte. And then back then, people's belief was that we're going to be seeing larger and larger models, and larger models is the way to go for computer vision. And that changed very quickly in 2015, where Google, I was lucky enough to be at Google, when Google started working on the model called GoogleNet, and drastically, the model went from 1 gigabyte down to 6 megabyte. So something like, how many? 100 divided by 6. It becomes like really, really more than 100 times more. The accuracy actually increased. And then basically ResNet built on top of that idea and basically started, like, still a bit bigger, but like very efficient computation, things like that. So we used to think in computer vision that models have to be really big, and it turned out to be efficient and small. Now, today we're actually looking at the large language models, and by definition, it's large. Right? So we started with like BERT type models, which is kind of small, and then very quickly there is this line of models that are super big. So Llama 7B is the state-of-the-art small model, and then right now the common models that people use are at the range of something around 70B for Llama, and then something around 50B or 60B for mixed-row and things like that. That's the common size that people feel in the open source world. So if you think about model sizes, when you think about large language model, you can think of it as something around 100B. We don't really know the exact details about closed source models, but some people say that, educated guess say that they are much bigger, but probably not going to be a magnitude bigger. One of the open questions today, of course, is, well, do we actually, need such big models? We're not quite sure yet. The general consensus today is that we do need a decent-sized model to be reasonably intelligent. And anything that goes under 1B starts sometimes doing mumbo-jumbo stuff, and then doesn't make too much sense. Right? But still, there's the question of, do we actually need such big and great models? One thing that we definitely found is that if you are having a specific vertical applications, then models are actually better fine-tuned with your vertical data. This is one thing that we kind of experimented earlier last year. Basically, the idea is that what if we want a financial service kind of bot trained on top of Llama that can answer questions when an earning report came out? So we basically crawled all the earning report transcriptions of all those like publicly traded companies. We trained a model and then basically tried to compare it against ChatGPT. And this is basically the result that we're seeing here. On the left is ChatGPT, and I think it has gone like much more smart. We fed in the Apple 2023 Q2 earning call. And we basically asked ChatGPT, can you talk about AI and things like that? And honestly, being a very honest and unbiased model, ChatGPT says, I don't know. Now, our bot basically says, And as I read, it basically says, sure, thanks for the question. It already started sounding like a CFO who's trying to avoid the question, right? And it basically says, and it says, we've been using AI in product for many years and things like that. There's a bit of, like these kind of like canned words, basically, like this is like, if I don't know anything, I'll just say those words, right? But we kind of checked against the transcript. It kind of makes sense a little bit and things like that. The idea is that with a little bit of fine tuning already, some sort of smaller models can actually be pretty smart. Now, in our daily operations, when we're actually like working with some of the clients and things like that, one thing we found constantly is that they find ChatGPT to be, especially GPT-4, to be an overkill. Let me take one example. There's one client of ours who's actually dealing with all those, like recruiting and job posting and things like that. One of their common use case is to basically take a job post or an email and things like that and do summarizations. What is the job title? What are the requirements of this job? What are the preferred requirements of this job? What is the location of this job? Does the job require being remote or not? Now, plausibly, you can understand that these kind of questions aren't really rocket science, right? It's not really kind of like trying to basically understand the strategy of Apple next year or things like this. Basically reading that email or that post and extracting key information out of it. So we found that actually, well, they started using ChatGPT. They was like, yeah, it's great, but it's expensive. And we're like, well, you can actually use Llama 7B with a bit fine-tuning, and it worked. So that kind of things are like constantly popping up quite a bit. Yes, sir.
I have some question about
Yes, sir.
this, because I understand if you will fine-tune the smaller model, would maybe do better for some particular task, right?
Right.
But is there any way we can also do some prompt engineering or something to fine-tune the output from ChatGPT to us to achieve a similar?
Oh, yeah, definitely. So ChatGPT is actually extremely versatile.
Right.
In the sense that prompt engineering gives you a lot of hidden power on top of something that's already powerful. So one thing that we often find the industry participants do is when they're starting doing prototyping, they start with ChatGPT. Because, well, at that point, product market fit or like feasibility is the most important thing, because we're actually spending people time in verifying that idea, and people time is expensive. ChatGPT in comparison is super cheap. And so basically like experimentation phase, ChatGPT, totally, absolutely, no question. And then when they go from that phase into the productization phase, and when the traffic ramps up and things like that, that is normally the time people start thinking about whether I can use some more cost-effective models or things like that. So that's kind of like the balance. Prompt engineering is by itself is a very interesting question, because like a few days ago, or a few weeks ago, people found that if you basically put in the prompt, and real thing, no joking, if you put in a prompt, I'll tip you $20.
Right.
ChatGPT gives you more versatile and better performance. It's like, yeah, $20, right? So not quite sure. We're still not quite sure what prompt engineering exactly does. It serves as some sort of regularization, right? Basically, if we use machine learning terms, in the past we used L2, L1 regularizations. Prompting is basically some sort of regularization, but mathematically it's still a little bit mysterious. It works, definitely, but still a lot of research are still going on over there. So basically, just to finish this fine-tuning kind of idea, then basically, like usually today, fine-tuning has been fairly standard. You collect a bunch of question and answer pairs, and you basically just feed it into kind of like, well, this is bullshitting about like the platform and things like that. I won't go deep into that, but essentially, basically, like you can just like fine-tune it with standard pipelines, and then you get a fine-tuned model, and then you will basically be able to put it into applications. One of the biggest questions, of course, is ChatGPT is an API that everyone uses, and then it has the benefit of scale. Right? A lot of people are calling that service, so it's able to, you just pay the API price per token. Now, if you actually deploy your own applications, one of the common questions people ask is it expensive? I need actually to have my machine up, right? And then when using APIs, if I don't use the API, I don't pay the cost. If I'm actually having my own dedicated machine, I pay the cost every single second, which is one big concern. So we did some sort of back of envelope computations and things like that to basically answer the question, is it expensive? I won't dive too much into details. Of course, having one's own LLM has the flexibility, the qualitization, well, the quality, the customization ability, and privacy and things like that, of course. But eventually, it boils down to the cost. Now, one thing that is contrary, actually, I'm going to be stating two facts that are actually pretty interesting. I would like to, let's say, the first fact is how fast is fast. Now, when we're talking to each other, when we're basically, listening to each other, things like that, we normally deal with words at a speed of something around 100 words per second. I was actually told by people that I speak too fast and things like that, and that's a bad thing, but I won't be able to go beyond 120. When we're reading, the reading speed of an adult in the States is something around 300 up to 350 words per minute, which basically means something around 5 to 6 words per second. And so basically that means if we are able to produce something around 20 tokens per second for an LLM, it's going to be already quite efficient for conversation models. Now, when we go to say code generation and things like that, the requirement is higher, but conversation-based ones, that one is kind of reasonably good. We've seen that, Chrome plugin, which is producing a notoriously amount of text, and it actually makes reading quite hard. So 20 tokens per second is something that's usable. So if you think about it, then using Llama 2 7B and those kind of fine-tuned models, you can actually run it on an A10 machine. An A10 machine is not too much expensive, and it's actually been able to produce a very large number of tokens per second if we use the recent optimization techniques, such as dynamic batching, such as quantization, such as speculative decoding, and things like that. That number, 25,000 tokens per second, is actually measured during, I think sometime like July last year, and by a bunch of recent optimizations and things like that, I think we're actually able to achieve something around 3,000 or higher. And by that computation, then actually dedicated LLMs actually can work out pretty well. And especially if you're able to do batch compute and things like that, then it's even cheaper. So personally, I'm actually quite confident and quite positive about the potential capability of everyone running their fine-tuned LLM models and things like that. And to extend on that a little bit, if you're interested in LLM systems, optimization, things like that, there are a few interesting projects or interesting open source work that's going on. The first one is VLLM. That's basically produced by Berkeley, a bunch of really great grad students. And they've written a Python-based inference engine that incorporates quite a bunch of recent optimization techniques. So dynamic batching, basically, as the request comes in, you add it to the batched compute dynamically. If something finished compute, you take it out of batch. That one. Quantization, they're working on that. Speculative decoding is one thing that's pretty cool. Basically, you have a smaller model that predicts what the next token or next set of token would be, and then you use the larger model to verify it, which becomes much faster, and all those such other things. There are also other kind of open source projects. MIT, the Sonhan's lab actually has one. I forgot the exact name. Actually, there was one paper talking about how to use how to basically reweigh the importance of the prompt to basically arbitrarily increase the potential prompt size for open source models and things like that. And by the way, there are some really awesome providers out there that provides you really fast LLM implementations. And I'd love to show you one company which is particularly interesting, which is Grok. You probably have heard about it. Please be able to do the demos, right? Oh, what? Now it needs login. How about that? All kinds of aliases and things like that. Continue. So the reason I want to show you this is a hardware company created by one of the co-founders of Google's GPU project. And before I show you that, let me proudly show you what our GPU-based implementation looks like speed-wise. Okay, so let's basically pull up Mixtral. And I'll basically ask it, and proudly, because that's probably one of the fastest LLM inference engines right now. So I'll basically say, tell me a very long story. Okay? And you can just feel the speed, don't read it. That's about the speed, right? Not too bad. And it's pretty fast, something around like 180 tokens per second or something like that. And this is speed that we can get from GPUs. And let me show you what Grok does. Now convert it to mixed draw. You can visually see the difference. Now, number-wise, the GPU-based implementation is getting something around up to 200 tokens per second. This guy is actually doing 528. Much better. And just for comparison, in GPU-based systems, you will be able to get theoretically maybe something up to 300 and not any higher, even if you have more GPUs stacked together and things like that, because all those, like inter-GPU communication, things like that gets into the way. Right. This guy, they use, they use SRAMs and they use, I don't know the exact details. Professor Chen is actually a much better expert than me in explaining this. But basically with, like a tightly connected 576 chips, they're actually able to achieve that speed. Now there's the argument about cost effectiveness and things like that, but purely by achieving that number, that sheer speed is actually something that's really interesting already. Right, so let's go back to the talk, and this is probably a good time for me to basically plug in the question that we had, which is basically the classical car salesman problem: good, fast, and cheap. Take two. Right. So let's first start with the hardware side. I basically just showed you two options. One is NVIDIA, and one is someone else. In this case, Grok. We've seen a few quite hopeful like candidates today, but normally, like when you look at it in the good, fast, and cheap kind of comparison, normally, basically, NVIDIA is one of the best compromises to get a good performance, a fast performance, a good user experience if you want to implement CUDA kernels and things like that, and is not that cheap, but one of the cheapest options that you could reasonably get today. For a lot of the chip vendors today, then they're able to get fast performance, but usually computation, well, actually like programming is pretty difficult. You won't be able to have some experience as similar to CUDA. You normally have to deal with, well, not as low as VHDL, God forbid, but still dealing with some sort of their own dialects and things like that. There are projects such as TVM, or recently Chris Latner, the creator of LLVM, has a startup called, Modular, and they have a new language called Mojo that arguably would allow you to program multiple hardware pieces and things like that more easily. But still today, it's a little bit tricky to deal with the good part. Now, if you look at the applications, actually, we already had this little conversation about, quality. Well, actually, for research, then you basically have to choose between OpenAI and open source. And then normally, OpenAI is, good, fast, not cheap. Open source is in some way fast and cheap, but not that good. So based on the application scenarios and things like that, you might want to basically consciously make compromises among these characteristics. Right. So what does this mean for cloud infra? We kind of started basically like I promised to explain what cloud infra would look like and things like that. So let me dive into that a little bit. First of all, what didn't change? Now, AI started with quite a lot of experiments and things like that, and we kind of almost, me personally, have always thought of AI as kind of like the what is the ivory tower research kind of things. We train a model, we tune the parameters and things like that. We do some evaluations, and then we're done with it. We don't worry about the rest. Turns out that when AI actually gets into products, that all those crazy historical, basically conventional cloud things just become a reality. This is yesterday. This is literally yesterday. One client told us, hey, you know what? Our online services running UAM model is having some sort of quality issues because we shipped a new model with too much quantization. And they were like, well, we would like you to basically revert the model back to an earlier version. We're like, okay. And they were like, just so you know, our whole website runs on this thing. So if you guys don't mind being a little bit careful about it, we really appreciate it. So we basically we assembled everyone. That gentleman on the right, that's the author of etcd, which is the database, under Kubernetes and things like that. We assembled everyone. We started basically like very carefully moving machines one by one, making sure that things don't go down and things like that. Everything you heard about computer systems, SRE and all those maintenance and things like that still holds in AI. It doesn't change at all. because it's still, at the end of the day, an online service, kind of similar to web services and things like that. It does have, a bit of difference though. First of all, there is, there's very heavy compute, and there's, and the number of the variety of the models are actually continuing to be like growing. If you think about web services, well, there's all kinds of HTML differences and things like that. But at the end of the day, it's kind of similar in a sense. You're just sending text files and images and all those other things to the client side. For AI, there's models that could be large, really large as a couple of gigabytes, in the sense that even downloading the model to start the service takes a couple minutes. There are smaller models, there are computer vision models and things like that. The models keep changing and keep increasing. The number of models on the Hugging phase is growing something way faster than the Moore's law. In August 2022, it's 65K. In September 2023, it's already something like 20 times larger. And you can see the similar trends when you look at the artificial intelligence hype cycle from Gartner. The reason I mentioned Gartner is that, for better or worse, outside the Silicon Valley bubble, which uses only one media to get new information, which is Twitter, then basically the whole world, especially conventional businesses, heavily rely on Gartner to understand what new trends there are in the new technology, emerging technology like AI and things like that. So if you look at hype cycles, there's quite a lot of things that are yet to go to the peak. Of course, there are some of them which are a little bit kind of like small to read, but like cloud AI services is actually like somewhere here. It's getting into products and going up. Things like knowledge graph and like Edge AI and things like that is they've had their hype, and then they're actually going back to more real kind of scenarios. This whole thing is going to be continuing for quite some time. And so those kind of things are getting into actually real applications. I flew in here this morning, and I have to share with you one interesting end-to-end picture of what an AI system would look like. Right. So my hometown is basically in a kind of like it's town next to Shanghai. So its air traffic is terrible. One, it gets very heavily eclipsed by Shanghai, and second, in August, there's all kinds of hurricanes and things like that. And so one thing you might kind of like not know is that for busy airports, the biggest downtime of those planes is not in the air. It's after the plane lands on the landing strip. Now, if you think about it, when you're taking a flight and you're basically like in the air, you don't mind if the flight's fast or not, right? You basically, you watch some movies, you make some PowerPoints like I did earlier today, and things like that. You're like, it's fine, don't worry about it. But as soon as your plane touches the ground, you're like, I have to get off. Like that gate is literally over there. I'm going to be running over there to get it off, right? So it's excruciating for passengers, because you know that now the time is being wasted. It's also excruciating for airlines, because they really want a very fast turnaround time. Anytime that planes actually land are there on the ground is time wasted, right? It's also excruciating for the airports, because if you ever heard about ATC conversations, if you ever listened to ATC conversations from JFK, it's terrible. The poor fact is that ATC guys, they have two things. One is their eyes. They have to be on a very high tower looking down, and all those crazy planes moving around, and they have to like, what is that plane, right? There are other options, radar. Those are basically two limited options, but everything has to be getting into their brain. And then, basically they started figuring out optimization routes and things like that. That is why the United States has the most grumpy ATC personnel, because that's just overloaded. Now, we kind of like back in Alibaba, we kind of worked on some projects called what is that called? In China, it's basically called like airline brain or things like that. We basically deployed a bunch of cameras across the airport. Combining that with the radar data, we'll be able to basically map out the whole airport and where the planes are and things like that. And then there's the conventional operation, research optimization kind of things to basically tell the ATCs, basically actually help the ATC guys what is the best route. It helps undiscover potential hot points. Sometimes personnel people, ATC people, out of habit or things like that, would like to route planes in such a way, and unintentionally they create some sort of congestion points in this airport, and we're able to, when there's data and analysis and things like that, being able to just optimize those contents away. As a result, arguably, it increases the air traffic flow significantly, although honestly, I didn't notice that. When I fly back to my home airport, it's still as congested as F, but you can see the idea of like how these functions could actually help personnel to get a wider range of knowledge, data of the real world, and basically make better choices. So among implementing those kind of things, one thing that we constantly come back and think about and find is the classical Google paper called Machine Learning, the High Interest Credit Card of Technical Debt. Right? ML code, ML model is actually one of the smallest part in this big picture, and there's quite a lot of crazy things around it when you actually want to build an application around it. How to get the data, how to actually clean the data, how to actually extract the features, how to actually verify data makes sense and are actually the same distribution as the real world scenarios. And then when you actually want to do survey and things like that, you want to make sure that services are not down, you want to monitor the quality over the time and all those kind of crazy things. Now, if you think about, so this is my educated guess, but if you think about the most recent release of OpenAI's Sora model, right? You'll find that most of the people, because they don't really release too much details, most people believe that the model itself is not that outrageously new. Basically, it's kind of a bunch of, like existing methods, VAE and things like that stacked together. But one of the greatest things, and one of the things that we kind of learn and admire OpenAI about, is that they've actually had a really great way to scale up stuff, both in data and in training, especially data, right? People guess that the really high quality videos generated by the OpenAI Sora model is actually thanks to quite a bunch of augmented training data from Unreal Engine. And if you play games, Unreal Engine is really awesome in creating 3D and perspectives and things like that, right? So this whole thing becomes a pretty big engineering kind of effort. Now, conventionally, cloud is actually offering things very different from AI. Now, as we mentioned, basically, like cloud actually started something around 2008 when David Patterson and the co-authors basically coined up the term data center as a computer. And basically, if you think about web services, there are two key needs that are out there. One is that I want elastic compute resources. Right? I have a website which has a lot of traffic during the day and have little traffic during the night. So I want to have an elastic supply of CPU machines, mostly CPU machines. And cloud basically says, hey, you know what? I can give you that. The second thing is basically, when you're actually thinking about building a website, there's quite a lot of crazy little, not difficult, but annoying software to install, right? You need a web server. You need some sort of a database for sure. You need a load balancer. You need some sort of message queues, Kafka or something like that. And you need an object storage. You need all kinds of little pieces. And it was like, this is going to be taken forever to maintain, things like that. Cloud comes in and basically tells you, hey, you know what? Don't worry about it. On the cloud, you'll be able to get all those software very easily with one click or little configuration, things like that. Essentially, the conventional cloud is basically providing two key values. One is the supply chain of an elastic amount of CPU machines. And the second thing is basically a very easy way to acquire and to deploy software that is fit for web services and all those other kind of online services. That's basically how the cloud offers, like what the cloud offers. In exchange, cloud is basically saying, hey, you know what? Let me charge a premium on top of the BOM cost of the machines. There's quite a lot of posts recently about moving off the cloud or basically like analyzing the arbitrarily bloated price of cloud and things like that. But essentially, cloud is able to charge that premium mainly because of these two things. One, a flexible supply chain, elastic supply chain, and two, easy way to acquire and deploy software. Now, this whole thing starts to change in AI because first of all, supply chain, right? We know that GPUs is an arbitrage market today. It's really difficult to acquire GPUs. And actually, like I'm pretty sure that as a research lab and small company as well, the cost of getting GPUs and using GPUs is a constant pain. And if you go to the cloud, one, price is really expensive, right? You rent GPUs for a year on the cloud, and then you calculate that you can already buy that GPU. It's like, what am I doing? Why don't I just buy it? right? And second is cloud GPU is not elastic. Now I can basically baffle for a whole day about I can basically complain for a whole day about why GPUs are actually not elastic and things like that, but it's not elastic. So the first value of supply chain is actually not too much over there. Second one, software. Now, if you think about running your AI applications, you never think about basically like message queues and load balancing and things like that, because you are just running that training or serving things like that. It doesn't matter that much to acquire and deploy software, especially the type of software that are actually only for web services. So you care about performance, you care about PyTorch and things like that, but the software is very different. And as a result, what we are seeing is that the conventional cloud providers, AWS, GCP, and Azure, are actually having, honestly, a challenge in the AI era in acquiring or basically keeping the customers. And I love to basically like coin the term called the return of MPI, if you're a Star Wars fan, right? MPI is this very classical computation pattern in scientific computation. So if you think about simulating large scale, I hate to say it, but nuclear explosions and things like that, or particle physics or large scale physics systems, starting from the 1960s, 1970s, there's this area called high performance computation or scientific computation. Its assumptions, I'm going to be using my computation resources, CPU or GPU, at a very high utilization rate, something around 60 or 80%. In comparison, online services usually run at something around 10 to 20% utilization rate. Second, I'm going to be having all those machines very tightly connected to each other so that they can do distributed computation. Three, I don't care too much about fault tolerance. If some machines go down, I'll just restart the whole process. And it's similar to what we do today with AI distributed training as well. And so as a result, what we're seeing is basically the emergence of quite a lot of alternative cloud providers. The most prominent ones are CoreWeave, Lambda Labs, and there's also a few others, and I forgot the name about. They're basically saying, hey, you know what, I'm just going to be giving you raw GPUs at a much lower rate than the cloud providers give you. And I'm going to be getting very highly interconnected networks, very fast storage, NVMe, and things like that. I'm not going to be giving you all those bells and whistles about load balance and things like that. And they're actually thriving quite a lot today. If you look at the AI world, a lot of the even NVIDIA is actually in some way, and I don't have concrete evidence about it. It's an educated guess by the industry. NVIDIA is subsidizing these companies by prioritizing the supply chain and things like that, so that there is better balance or a better cost effectiveness of GPU supply chain. And I think cloud is actually going through a mindset change. In the past, cloud mostly thinks about web services, load balance and things like that, and basically doing supply chain more efficiently and doing software deployment more efficiently, and then charging a high premium. But today, we are going back to this 1970s kind of needs, not the technology, but the needs. And we're actually starting to rethink how a compute-heavy and less I/O-heavy, especially compute-heavy and heterogeneous computing environment would shape the infrastructure. There are quite a lot of clouds that are actually stripping away some of the things that you've heard about. So virtualization, for example, and also some other kind of things like batch compute and things like that, I guess less important in AI. So cloud providers are actually also kind of reshaping their product offerings so that people will be able to run AI on top of it. Amazon AWS has an AI platform called SageMaker, which supposedly is modern and things like that. But interestingly, inside SageMaker, they offered a product called Slurm. And if you're familiar with type of computation, that's some of the infrastructure that's existing since the 1970s in all those large national labs. That gives you a very simple way to actually manage compute. So that's why I think cloud is also kind of going back in time and basically giving us more kind of conventional computation infrastructure that actually matches the AI compute. Now, we honestly don't know in this crazy land who's going to be winning the AI infrastructure war. But Andreessen Horowitz has been constantly tracking the change, and this is their depiction of what this AI software stack looks like. At the very bottom, there's compute hardware, NVIDIA's leading, and everyone else is basically following. There's cloud platforms. So basically there's AWS, GCP, Azure, and they actually, interestingly, also put one of the biggest alternative cloud providers, CoreWeave, today. Yeah, I can talk more in more detail about CoreWeave if you're interested, but let's put it over there. On top of that, we see more and more AI native applications emerging, either using open source models or closed source models like OpenAI, and start building applications on top of that. Over the last year, I think we've already seen applications coming and going and coming and going to basically test product market fit. And I'll particularly mention one application because that one was like the one that I made the biggest mistake on. In 2022, there is a very popular application called Jasper AI. You might have heard about it. Jasper AI uses ChatGPT API to basically offer people easy ways to write articles, to basically modify the articles, to improve articles and things like that. And it's very popular among editors, basically, whoever wants to create content. Now, for better or worse, then ChatGPT started kind of going into that space as well, because today ChatGPT is like super easy to use and things like that. So Jasper AI suddenly like went from being the most popular AI app in the Silicon Valley that everyone talks about, suddenly to some app that people feel bad about because it just gets eclipsed by ChatGPT, which was back then its service provider. So this whole landscape is actually like changing drastically. But one thing we constantly found is people might need to have some differentiating powers. Wrapping on top of ChatGPT API is probably not the moat that one is thinking about. The emerging companies recently, for example, 11 Labs in an audio recognition, and the Mixtro, for example, for in like large language models, open source models, Perplexity AI in more conversational search and things like that. They all have some unique capability on top of being like, in addition to being only just an open source, well, an API wrapper. And they've actually been driving quite a lot of the infrastructure changes and things like that as well. And we kind of feel that, you know, like whoever who's actually closer to the applications, whoever who is actually able to acquire customers, is probably the one who's winning out. So if you're thinking about doing a startup, and I'm not quite sure if it's right, but it is proper to basically solicit PhD students or master students to do a startup, but whatever. If you're thinking about doing a startup, then basically, like, I think right now there's quite a huge amount of opportunity to basically rethink how AI would be changing the way we use conventional software and we solve the conventional problems. We constantly feel that AI is actually not really like a new application. It's just like the productivity tool that will be drastically changing the way we think about old ways of, let's say, conferencing or writing or other things, right? So if you're closer to the applications, I'm pretty sure that, you know, like the winners are going to be coming out of those. So last page is one to basically like doing a shameless advertisement. We kind of started thinking about that trend, and we're like, well, we're a bunch of dudes who are actually just like who have written too much code. So we just want to make sure that, you know, yeah, infrastructure is as easy as possible. Imagine if, you know, like you can basically launch your large language models as easy as possible in less than 30 seconds, and then start, you know, like spending most of your time actually thinking about how those kind of like how you can build an application that changes how people, like changes the way people deal with their daily tasks. That'd be pretty great. And we'll be basically with the infrastructure under it. We kind of strongly believe that AI, being the third pillar of infrastructure, has a huge market. And you know, like if you're interested in being, you know, like basically trying things out or like learning some like LLMs and things like that, it's an open platform. You can just register and just like get machines and stuff like that. So definitely try it out, and let us know if you run into any problems. And with that, I think it's 11 o'clock, and I'll just like conclude my talk. And thanks so much for inviting me.
20 minutes. So any questions from the audience? Just raise your hand.
Can I ask a quick question? Can we use the Neptune AI to read papers?
Possibly, although we don't really have the PDF capability yet right now. You can definitely read New York Times post, by the way, and actually go through the paywall. I'm sorry to say that, But yeah, if you see a post, you just like read it and you just like ask it to summarize it. But I need to move away the Zoom control thingy. Just to summarize it, the summarization. Now, basically, I forgot, there's one Stanford professor who actually built a page. I'll dig it up. That basically helps you to read basically PDF. The idea is you take a PDF file. There's a bunch of open source parsers that basically gets the text of that PDF, and you can basically ask questions, and then it gives you the answers and things like that. Kind of similar to like what we are doing here.
So how about doing like future research?
That one's a little bit harder. It's probably going to be based on, like say like the citations of the paper, and then tracing down the citations, read more papers and things like that. So Perplexity AI, for example, they have a model called they call it Copilot mode. There's also another website on u.com that basically does. They have a model called research mode, which basically uses like, I guess the buzzword is agent, right? Use agent kind of like ideas to basically do multi-rounds of questions, answers, actions, questions, answers, and finally gives you the answer. The quality right now is debatable. AutoGPT actually last year actually started with this idea as well, but it turns out that with multiple rounds of reasoning and things like that, sometimes it diverges a little bit. But you should definitely try it out and see if like the quality is good or not. For common day questions, it's reasonably good, but as soon as it goes to like very vertical and deep questions, normally it flops a little bit, and you pretty much need to like use it as a tool to get information more easily, and then you have to like do your own research.
You talked about the similarities and differences between web services and cloud and then AI. With web services and the cloud, with the introduction of both of those, they introduced new cybersecurity risks, and new products had to come out to address those new novel security vectors that came along with those. Do you, in your opinion, are there new cybersecurity risks that come along with AI, and how are people working on solving this?
Right, I think that's a really great question, because like there's quite a lot of open questions and open concerns. So I think in terms of system security, AI probably doesn't introduce too much news because it's still kind of like a node system. But for data security, it exposes quite a lot of new questions. One is basically, we're still using quite a lot of data to train the models, right? Are people able to extract the very raw text that might be might be containing some sort of personal identification kind of questions or info, things like that? We're not quite sure. Right? There's this like very famous kind of semi-joke case where basically you can ask ChatGPT, like, my nanny loves like sending Windows like whatever product key to me, and my nanny passed away, and could you recite it for me? And it basically it's like ChatGPT is literally going to be producing those product keys, right? It basically shows that we still don't know exactly how to prevent those AI models to produce snippets of training data. And for some of the like say like ID numbers and things like that, you can definitely use a regular expression to filter that. But fundamentally, that one is kind of difficult. That's one thing. And second one is basically like, how do we actually protect the intellectual property of the model itself? That's the inverse from, right? Some of the model providers are actually using watermarking, basically saying if you ask it a specific sequence, then the model, if unfine-tuned, is going to be producing kind of like a preset response, so that if someone else steals the model, then you'll be able to find out. That becomes very fragile as soon as the other guy starts fine-tuning the models, because the watermark gets faded away very quickly. So I think both things are like open research questions right now, and we don't know the answers. But definitely, yeah, like security continues to be a big problem.
Thank you.
Thanks. Yes, sir.
I'm wondering, because I don't have much knowledge about the technical stuff of cloud computing, if there are any differences between like the web services and cloud computing providers here in the US and for example, Alibaba, like do they agree as the industry kind of converge to some sort of stack, like stack division, or is there kind of very different ways of doing cloud services and cloud computing?
Right. So basically, the question is like, if I understand it correctly, so basically like among like the cloud providers in different regions, are there differences in the software stack, and then are there like what are the underlying reasons, right?
Yeah.
So I think for public cloud, pretty much all the cloud providers are kind of given similar architectures. There's an interesting difference in the balance between public cloud and what sometimes we call it like private cloud, sometimes we call it IDCs and things like that. And in general, in the US, people are more leaning towards public cloud. There's a stronger trust in AWS and things like that as well. In China specifically, and in some of these like Southeast Asian countries, there is a preference towards more private cloud kind of deployments. One is people feel more secure having their own cloud, and there are also kind of some other economic reasons. So in the US, especially in the Silicon Valley, people don't really want to spend a lot, people don't really want to hold a lot of capital. Capital heavy is something that's negative. In China, Southeast Asia regions and things like that, conventionally, the main business is actually manufacturing, and then capital is actually a good thing because it means that you're having the machines to produce stuff. And that mindset changes relatively slowly. So basically, people actually want to buy machines, put the machines on the IDCs, to have the machines on the cap table. The other rational reason is because in a lot of these countries, the state, actually subsidizes capital expenditure. They're going to be giving you low interest loans for you to actually, build a GPU cluster, for example. And so rationally, the balance between public cloud and private cloud is a little bit different. In terms of the software stack, things are more similar than not, especially with open source software. Yes, ma'am.
Yeah, I think, yeah, as you mentioned, like probably compute is going to be more of a hassle than IO in the future for cloud, for AI. But do you see any like also fundamental change in data pipelining in the same process? Because you also mentioned like fine tuning and stuff, and I'm assuming that for those services, like data will be the key.
Right, yeah. So I think one, data continues to be extremely important. And second, when we think about system components, I think in the past, people basically, well, actually still today, people argue whether data and AI should be two things in one system, such as what Databricks might be saying, or a sibling system side by side. Now, I am leaning more towards they're actually sibling closely related systems, because for big data or databases, actually I/O versus compute is actually kind of one to one or something like that, right? You move data around and then you do a little ETL and things like that, but not too much compute. If you think of LLMs, well, you put in 4K context, you get, like say something like a couple K output, but the computation is huge, like thousands or even millions to one. So basically what would happen, I guess, is basically we're going to be still using conventional data infrastructure that's closer to like with the data dumped from web services. We're going to be doing ETLs, data clean and things like that. We'll be dumping a clean database, well, actually a clean data set. We'll just copy that data set into the Slurm cluster, whatever it is, put it in the local NVMe, and then start training. Because we're going to be chewing through those several gigabytes or hundreds of gigabytes of data a lot of times. And compute and being close, having data being close to high performance computation is actually key. And it's actually easier to design the system with data and AI side by side rather than smushing them together. And that's like our thought.
Do you also provide such services?
So we don't really provide data services because there's awesome data infrastructure out there, and usually you just stream data. Well, actually, you just move data into the cluster and it works. Thanks. It's I was there down there. Yeah.
Like you mentioned, the one challenges in the AI infrastructure is the scalability of GPU. So,
right.
My question is, what is the property that prevents these cloud providers to virtualize this GPU?
Right. Yeah, that's a great question, actually. We haven't really touched that technical point yet. So basically, first of all, if you think about CPUs are extremely versatile in repurposing themselves to different tasks, right? So one of the common patterns that we see in web services is during the day, there's a lot of online traffic. People are visiting the websites. Now, in the night, that thing dies off. But in the night, we can actually do quite a lot of offline big data operations. Taking Alibaba, for example, during the day, there's a lot of people browsing stuff and buying stuff and things like that. In the night, my big data system goes in and starts calculating the bills per bank and things like that, right? And CPU can be repurposed here or there. GPUs are more narrow. It's good for AI compute and numerical computation, but if it's idling, then you can't run a database on it. You can't really run web services on it, things like that. Making GPUs a more, well, basically it's an arbitrage kind of market, right? Basically, like you have to basically, for CPUs, I can basically have someone come in and basically I'm going to be only using it for a day and I'm not going to be paying the cost for the night. But for GPU, I won't, because if that person is only paying for the day, there's no way I can sell it for the night. So that's why GPUs are like naturally when you want to reserve a GPU, people actually tend to basically give you a high price on demand, or you have to do reservation 1 year or 3 years term. So that like the provider doesn't incur a big idle cost. That's one thing. And the other thing is basically like GPU today, the supply chain is actually pretty tight in the sense that like I don't think NVIDIA back in 2012 or 2022 realized the high popularity. And as a result, all those supply chains, all those silicon supply chain actually works in like 6 weeks, 6 months back, right? If you want GPUs, you will have to have like TSMC give you the bandwidth, right? And then basically TSMC has to go to the wafer company and basically say, hey, give me those wafers. And so I think the whole world is actually experiencing a shortage in semiconductors to the extent that 2 weeks ago I was actually in Japan. So Japan has those IC cards for you to take subways and things like that called Suica. And I landed and I was like, ooh. Suica basically said, because of the global shortage of semiconductors, we're actually not selling Suica cards. I was like, oh, damn, right? So it actually is constrained by supply chain. Now, the third thing is, of course, basically like right now, there isn't an alternative to NVIDIA GPUs. The closest one to NVIDIA GPUs today is AMD. NVIDIA has a really nice software abstraction called CUDA, and no one else has it. Over the years, starting from 2016, 2017, AMD started realizing that there's no way to basically rival NVIDIA by having yet another abstraction, because people like me just hate learning things, right? We're sticking with CUDA. So AMD is like, hey, you know what? Let me actually provide a CUDA compatibility called ROCm, or the translation layer is called HIP. They're actually reasonably good today, still a few rough edges and things like that. So we're seeing potentially an NVIDIA rival. The challenge comes from multiple parts. One is still a little bit buggy, pretty good, by the way. And the other thing is price is not the best still. NVIDIA is like basically saying, hey, you know what? If you buy an NVIDIA box of 8 GPUs, it's $260K. And if you buy AMD, I'll give you a little bit cheaper price, is $240K. And we're usually like, well, it's not worth the trouble to save $20K, right? So all those kind of things are still kind of like going a little bit slowly, but hopefully we go from like a completely arbitrage market to a more free market where the efficiency of the users, I don't care about the infrastructure side, they'll suffer, but the user side will have a much better time getting heterogeneous computation and start running their applications.
So it's not like the technology problem.
Yeah, a lot of things are technology, are non-technology. So if, you know, like suddenly we have like, say, 10 TSMCs, I'm pretty sure that supply chain problem will just wait for it. Yes, sir.
I wonder what's your opinion about how startup in AI like nowadays? Because like you mentioned that who is closer to the application who may be like more likely to succeed. And
right.
And like your example, the Lepton extension.
Right.
I remember that Microsoft also has a similar product.
Oh, definitely, yeah.
Yeah, but like if I'm the user, like there's a built-in product, and it may be not that efficient.
Right.
I may probably choose that. So.
Right. Yeah. So the question is basically like, how do startups compare? How do startups like fight big players, right? So I don't really have an answer. Actually, you know, our big players are hugely powerful in the sense that, for example, we raised, you know, like say something around like tens of millions of dollars funding tops for a Series C or A company, right? One of the most powerful thing that big companies can do is basically say, I'm going to be selling my product for $0. And you don't have any money, you have infinite money to basically just squeeze it out. Now, the good thing about startups is that, you know, like for better or for some strange reason that I'm still kind of like trying to figure out, people are more forgiving to small when they're actually using small startup products. For example, let's take a search for example, right? So if my model hallucinates, you'll be like, it's a startup. That's cute. It's fine. But if I'm Google and you do some search, for example, where's the nearest Starbucks, and then Google gives you an answer, and you drive there, and you're like, there's nothing, you will be criticized like, what is Google doing? It's so stupid, right? So because fundamentally, you're actually thinking of small startup products as an exploratory experience. You want to find out what kind of new things, new interesting, valuable things that you will be trying out next, and you're more forgiving. Google has already been one of your utility, and you don't want it, in some way, you don't want it to change. You want it to be stable. And that's where innovation has the opportunity to grow from a smaller one to a big one, right?
Yeah. So how you handle these kind of questions?
I think basically like user experience is key. And understanding where efficiency comes out of is key. And also moving really fast is key. I think that's pretty much it. Yeah.
Thank you so much.
Thanks. Yes, ma'am.
Have you ever considered to focus on like product in specialized industry? Like some may not.
Yeah, so the question is basically like, do we want to do verticals rather than more like horizontal platforms, right? It's one is basically like there are really smart people doing different vertical applications and things like that, and we see ourselves, like our experience and our expertise are more like on the horizontal infrastructure side. So it's more of kind of like I guess it's like a self-fulfilling prophecy in some way, right? And also looking at our expertise things. Maybe one day we're like, oh yeah, this is really cool. We're going into like say healthcare, but right now we're still staying on the infrastructure side.
Yeah. Can you explain how many like active users you currently have, and how do you plan to promote your product?
I would probably not mention the active users, but yeah, well, basically like I think a lot of the Silicon Valley startups basically think about growth in a product-driven way. So normally there are two ways of driving adoption. One is product-led and one is sales-led. Sales-led usually works really well in enterprise applications or things like that. And product-led is more lightweighted and things like that. I think we follow the same way as well, but and the general Silicon Valley thought is basically the founders, for better or worse, has to drive adoption and drive revenue and things like that to a certain extent without sales. Because, well, if a sales comes in, it's like, well, I'm ready to basically take a fixed recipe and start scaling it. And if there's nothing, the sales are like, what am I doing here? Right? So founders basically start going to the clients, sell the very first few deals, and we've signed a few deals, and basically, and then start building a recipe, a pipeline, or whatever we call it, so that, like salespeople with their expertise in scaling will come in and basically scale the company. Thanks.
Quick question on Zoom. By the way, you had about 55 people watching you on Zoom.
Oh, awesome. Yeah, thanks.
The question is regarding the version of ChatGPT you used for your testing. And if you use a more recent version, will your results be different?
Yeah, so we don't use too much ChatGPT because we don't really build applications, but we sometimes, for example, if we want to like augment the training data, find ground truth or things like that, we use ChatGPT, and mostly it's like whatever the newest version it is. There is indeed one of the tricky situation, which is like every time a new version changes, actually the statistics, the distribution output changes. We deal with it in a stupid way, which is like we just like flush the whole data. But yeah, there isn't a good way to basically guarantee like model. I guess like what is that thing called? Like basically like the distribution model, the distribution output changes. So basically, that's why also sometimes people would love to have their own models because it's more controllable. And OpenAI doesn't really guarantee that a specific version is going to be like existing forever. So that's one of the benefits of having one's own model. Thanks.
Maybe the last one.
Yeah, so
Yes,
like what are the better or promising like AI investments track, like according to your opinion, like because you have been like a pre-VC in Alibaba,
right.
and also from Zhejiang, like so I'm really wondering what's your opinion of that?
Yeah, so that one's a tricky question that I haven't really made money for my investors yet, so I'm not sure if my answer is credible. But the question is basically like what are the opportunities in the AI investment field? And I think right now, basically people, different VCs definitely have different opinions, and large language models, creating the next large language model and image model and multimodal model that could rival OpenAI. That's one of the biggest topics. And you can see companies like Anthropic, Cohere, Mistral, and also there's a Chinese company, Moonshot AI, which recently raised $1 billion. That one is big bet, big gain, big risk kind of phase, because you throw in $1 billion and then, you train a model. And if the model is bad, then you're dead. If the model is good, then luckily you have 6 months shelf life to monetize that model, right? That's why there's a lot of pressure. So that's one part. And the other part is there are also kind of companies that are basically using AI to change productivity, to improve productivity. In the enterprise world, for example, enterprise search has a company called Glean, Glean, that is basically solving the very conventional problem of how do I actually search in a company database and then get informative, accurate results out of it, right? There's another company, I forgot its name, that focuses on actually doing post-mortem analysis of company, of technical, incidents or things like that. Some incidents happen, a bunch of people group in, there's Slack channels, there's GitHub issues, there's documentations, there's individual conversations going on to solve that issue. And then normally the conventional problem is that, when people start writing post-mortem, it's like, what is the cause of this issue? It's unstable. But how do we fix this issue in the future? Make it more stable. Because people are so tired that there's no reason writing that post-mortem. All those golden data is actually out there. We just need a smarter system. And there's a startup saying, hey, how about I solve that problem, right? So I think those are more vertical. It's small investments, as long as this usually comes from domain experts who actually understand the problem really well, and they just need AI help to make it more efficient. That's smaller bets, maybe smaller kind of like returns, but yeah. I think it'll make very big differences in specific fields. Thanks.
So this room is packed by more than 80 students and also the audience. So I think we'll give applause.
Thanks so much. Thank you. Oh, thank you.
Yeah, I think we're gonna do that.
I will start. Right on.
Yeah. Thank you so much.
All right, thank you. Right, I was gonna say that. Yeah, yep, got it.